heated up, and then the red dye gets trapped inside the bacteria, and that's why it turns red. It's a very, very difficult organism to treat and to vaccinate against. The field in general over the last 25 years has made enormous advances into understanding the physiology of the bacterium, understanding its structure, understanding how the immune system sees it. You could make the argument that 15 years ago we thought we were making some headway. But then what happened was the HIV epidemic. And this is just like dynamite for tuberculosis, because the HIV virus will destroy your immune system. And that makes TB highly infectious, highly transmissible. And so now we're seeing a resurgence of huge numbers of cases of tuberculosis, particularly in places like Southern Africa. We're seeing increasing cases in India and China. The other problem is that about 500,000 new cases a year, of the about 8 to 9 million new cases that we're seeing, about 500,000 of those are resistant to several of the first-line drugs, what we call multidrug-resistant TB. I had trained as an immunologist in England, and I went into it because I was interested in the immune response. I wasn't interested in disease or drugs or vaccines at that time. I just wanted to know what the immune response was doing. But by developing models to figure that out, that opened up this enormous avenue for applied work in drugs and vaccines. I think we understand most of the nuts and bolts of the immune response to TB. There are certain aspects of it we don't still understand. And very recent work in my group over the last 2 or 3 years has identified at least 2 new populations of T cells that we didn't realize were there before, which are really a spanner in the spokes here. They're T cells that we think turn off immunity. We're very worried that these cell populations are going to interfere with the efficacy of the vaccines that are now being sort of tested, or soon to be tested in South Africa. So that's primarily where my research is going at the moment. But we are still sort of interested in developing our own vaccines here, and we've focused actually on making a post-exposure vaccine. The concept that you would be exposed to MDR-TB in a metro, train or something, or an aircraft, and indeed that's already happened, where you might say, well, where's the vaccine? I need to be given a vaccine. Giving a vaccine before exposure is one thing, and that's really what we've concentrated on. But what my lab is trying to do at the moment is to develop a post-exposure vaccine. And that's another level of complexity altogether. It's turned out to be extremely difficult to get these things to work. But we are making a little bit of progress in that respect. I think it's true to say that over the last 25 years, our TB program has made a really major contributions to the field. And I think it's been an incredibly successful program.